Hey, hello and welcome to today's GFG POTD problem, Bleak numbers. So let's say what the problem has to say. Given an integer, check whether it is Bleak or not. A number n is called Bleak if it cannot be represented as a sum of a positive number x and set bit count in x. Okay, that is x plus count set bits of x is not equal to n for any non-negative number. Oh, okay. So what the problem is trying to say here is given a number n, a number n is called a Bleak number if there is no such number x plus the count set bit of x. If there is no such number x whose sum is equal to n. Okay. If there is a number x and add in addition to the set bit, right, the set bits of number x, right, if there is a sum of x whose which equals to n, then this number n is not a Bleak number. So for example, let's take an example of n as 3, right? So there's a number 2, for example, 2 plus how many set bits are there in 2, right? So the binary representation of 2 is 1 0. So there is one set bit. So 1, 2 plus 1 equal to 3. So that means 3 is not a Bleak number because there's a number 2, right? Which whose addition to its set bit count equals to 3, right? Similarly, there's number 4, right? 4. There's no such number, right? Whose like this addition, whose addition, there's no such number as x, whose addition to its binary set bit count equals to 4. Okay, so 4 is a Bleak number. Okay, 4 is a Bleak number. So how can we proceed this, right? How can we proceed? Now, if we see the range of n, right? The range of n. What is the range of n given here? The range of n given here is 10 to the power 9, right? 10 to the power 9. So let's see, I mean, what we can we do something about this range, right? So simple, like if we if we think of some naive solution, right? So what we can do is we can iterate from I equal to 0 to 10 to the power 9 simply, or n, right? Or n, not 9 or n, whatever n. And what we can do is I plus, will calculate the set count bit of I, right? If it equals to n, right, if it equals to n, that means it is not a Bleak number. Okay, it is not a Bleak number. You have to return 0, right? We have to return 0, else you have to return 1, right? This would be naive solution wherein we will have to iterate from I to 0 to complete n, right? From I to 0 to complete n. This will give you the solution, right? I plus CSB of I, will have to write the count set bit function, right, which will give, right? But let's see if what will be the time complexity here, right? What will be time complexity here? N into log of n. N for, like, we're iterating this complete n, and CSB, right? CSB gives log n time complexity. So n into log n. So let's see if we have some better approach to solve this problem, right? Let's see. Now, as we have seen, right, the range given was 10 to the power 9, right? So what we can we do something about this range, right? So what we can do is, like, n can reach up to 10 to the power 9, right? 10 to the power 9. So what formula we have here is x plus CSB of x, right, equal to n, right? And the range of n is, the range of n is 10 to the power 9. So if we see what is the binary representation of n, right? N, if we consider max as 10 to the power 9, 2, 3, yeah, here we have 10 to the power 9. This is a 10 to the power 9 number, right? 10 to the power 9 number. If we see, we get the binary value as this much. This is the binary value, right? This is the binary value. If we remove the 0, so we have what? How many numbers? 30. Max 30 bits we can have in this 10 to the power 9 number, right? So what we can say is max 30 bits can be set bits, right? And minimum 0 can be the set bits, 0 to 30, right? Because the length of this binary representation is itself 30. So max 30 bits we can have, right? So if we can see, so now the problem can be reduced to, so how many set bits can we have of x can definitely can go till 10 to the power 9, right? We saw in this implementation, right? We were going till n, 10 to the power 9, right? Or n, max n we were going, right? So we saw that uh, max 30 we can have, right? Count bits max 30. So what we can write here is x plus 30 equal to n, right? And what x turns out to be x minus n minus 30, right? So this 30 can have, like, the range can be 0 to 30, right? So the range of x will be x minus 30 to n minus 30 to n minus 0, right? Because in the binary representation, the length of bits would be 30, max 30, and set bits can be 0, range 0 to 30. So our problem turns out to be x equal to n minus 32. We have to calculate for this only, x n minus 30 to n minus 0. So if we quickly write the code, right? So what the code will be, what the pseudocode will be for int, for sorry, for x equal to n minus 30 to n, right, to n, right? And what we'll simply do is, if x plus csv of x, if it is equal to n, return 0, else, right, else return 1. So let's quickly implement this and see if it is working, right? So now what we'll write, as we saw, int x equal to uh, n minus 30, right? As per the given range, x is less than equal to n, sorry, x is less than equal to n plus x, right? If x plus csv of x equal to n, that means it's not a Bleak number. We have to return 0 in this case, else we have to return 1, right? And let's say int csv, right? Int, for example, yeah, let's say x, right? Or maybe, yeah, whatever you consider. So yes, it's a simple CSV, that is count set bit function, right? You must have seen earlier. So what we'll do is, while x is greater than 0, right? So we'll have a one count function in cn count of set bits, right? If x and of 1, right? We have to see for the last bit. If it is greater than 0, right? We have to do simply count plus plus. Else x, we have to shift one bit, that is divided by 2, right? So that one bit will be removed from the extreme right, right? And we have to return cnp, right? CSV plus cnp, right? So x plus, right, the CSV will give the number of set bits, right? If it is equal to n, then we'll return 0, as it won't be a Bleak number. So yes, let's see now if a solution is accepted. Yes, it is accepted. So thanks for watching this video. Like the video and subscribe to my channel so that it will motivate me to create such videos for you, such solutions for you. Thank you so much.